This lecture is about the Boston house price prediction. The Boston dataset has a number of features. It includes the per capita crime rate by town, the proportion of residential land zoned for lots over 25,000 square feet, in thus which is a proportion of non-retail business acres per town, the Charles River dummy variable equal to 1 if the tract bounds the river and 0 otherwise, the nitric oxide's concentration, the average number of rooms per dwelling, proportion of owner occupied units built prior to 1940, weighted distances to 5 Boston employment centers, index of accessibility to radial highways, full value tax rate per dollar 10,000, people to teacher ratio by town, the black proportion by town, and the percentage of lower status of the population. So these are the variables and these are used to predict the price of the house. So what we will do is that we will find the relationship between the lower status and the median value of the owner occupied homes. We'll find the relationship between age of the houses and the median value of owner occupied homes. We'll use multiple linear regression using LSTAT, which is the percentage of lower status of the population. Multiple linear regression using all features, multiple linear regression using all features except tax and all features except in thus and age, and also we will use using featured interactions. So let's jump in and see of how this is done. So the first part is that we will import the libraries, we read the data, and it has some serial numbers here. So we make it the index column by making index column equal to 0. And this is what we are going to predict the median value of owner occupied homes in thousands. And there are 13 variables. We plot the lower status and the median value of the owner occupied homes, and you can see here that it is highly negatively correlated. That means as the lower status value increases, the median value of the homes decreases. Then we do a train and test split, and what we are doing is that we are making the features as LSTAT, and we are using the median value as the predict as a variable which we are going to predict. We make a train test split, and then what we do is that we are doing a single linear regression, and you see it is the same strategy that we are adopting. We are using we are making a model, we are splitting using the train test split, we are doing a model dot fit to create the model, and then we are doing the predictions, and then we are using the RMSC, that is NP dot square root of the matrix dot mean squared error, and this is 6.65. That is the RMSC, that is the root mean square error. We also plot the age of the houses and the median value, and here also we see that it is practically negatively correlated by using this line. That means as the age increases, the median value decreases. We are using multiple linear regression using LSTAT and age, and the value to be predicted is the median value of the price, and we see that the RMSE is 6.5. So we check whether that it has increased from the previous one or not. So it is also 6.65, and here also, okay, it has decreased by including the age. If we include all the features, that means what is there, we find that the RMSC is 5.45, which has decreased quite a lot from the previous one, which is 6.56. We then do a correlation map, the heat map, and we can find the various values. Now, we find that uh, if we drop tax, so what is the correlation between tax and MEDV? So MEDV is here and the tax is here. It is minus 0.47. So if we drop tax, then it becomes 5.52, which is which has not which has not decreased, it has increased. By dropping in thus, it has become 5.45, which is also not very increased. If we drop both in thus and age, it is becoming 5.44. That means, and let us see whether it is improving from all the features or not. So all features is 5.45, the RMSC, and by dropping in this and age, we are getting 5.44. Here we introduce a new concept known as feature interaction. So what is feature interaction? So let's jump in and see a definition of what is feature interaction. So a feature interaction is something like a feature cross formed by multiplying the values of two features, which is feature is A and feature is B, and we obtain this new feature. Similarly, if we have 5 features and we can also maintain a cross and we can create a variable with 5 features, A cross B cross C cross D cross E. A feature cross formed by squaring a single feature, we are also getting this. So this is the feature interaction that we are having. So here what we do is that we create a feature interaction using LSTAT and age. We are getting this. And what we get is that uh, this one, which is 5.4460, and not much of a difference that this is getting. But this, what we have done through this session is that we have investigated that we can do multiple linear regression with a number of features, as well as we can also create features using the multiplication of two features like LSAT and age, and we can create new features through this. Hope you liked the lecture in which we demonstrated various strategies of doing multiple linear regression. Thank you.